108, we've got a damped harmonic oscillator consisting of a block and a spring and a dampening force. Initially, it oscillates with an amplitude of 25 centimeters. Because of the dampening, the amplitude falls to 3/4 of this initial value at the completion of 4 oscillations. A, what's the value of B? And then B, how much energy has been lost during these 4 oscillations? So here is the new omega due to a damped oscillator. Now I'm going to argue that for all practical purposes, this dampening portion right here is not going to affect it a great deal. So for my first approximation, I'm going to say omega is just equal to the square root of k over m, meaning our period is the same as a mass spring oscillator, just that. We'll talk more about this approximation later, but if we do that, we can plug in our numbers and discover the period's about 2.81 seconds. So how long is the time for 4 of those? Well, just that answer times 4, 11.2 seconds is what we're looking at. So here's our equation then for a damped oscillator. In particular, I'm interested in the magnitude of it, so I'm going to ignore the entire cosine portion of this, where again we have amplitude times e to negative bt over 2m. And we want to know when the amplitude becomes 3/4 of its original value. Officially on this one I should have a sub 0, but forgive me. Dividing both sides by the amplitude gives us this. We're plugging in the 11.2 seconds that we got from over here, and we're plugging in our mass, which is 2 kilograms from up here. Solving that, natural log of both sides gives us that. You can do a little bit of algebra, and you'll discover that B is 0.102 kilograms per second. I've added a few more decimal places here just to show you the difference. All right, so you might say, well, that was kind of cheating. Let's go do it the full way. Well, if we plug in our numbers, we know everything except B, so omega prime is just equal to that. Simplifying it down, we get that, which you could reduce to this, moving the 4 out of there. Period, our period prime is going to be equal to 2 pi over omega prime. Plugging in our answer there would give you this, moving the 2 up to the top. And then we can plug it into here. Please notice the 16 up on the top here. Why did it become 4 times larger? Well, because there's that 4 oscillations we're talking about. I didn't go ahead and do it a separate step. Now it's just a bunch of algebra, and if you do that, you'll discover it's this. To 3 sig figs, it's identical. Actually, even to 4 sig figs. But if you go to 5 sig figs, you'll notice that it is actually different in the 5th place. So our approximation to start out with was absolutely fine. And to 3 or 4 sig figs, you are absolutely golden. Part B, how much energy has been lost? Well, if you remember, the energy of an oscillator is 1/2 Ka squared. In this case, our change is the original amplitude to when it goes down to 3/4 of the amplitude. If you do that real quick, you'll end up with 7/16 A squared is that term there. 1 squared minus 3/4 squared. Plugging in our numbers, K is 10. The initial amplitude is 0.25. And if you solve it, you get 0.137 joules have been lost. I hope this much makes some sense. Good luck.